Qué bueno que vino José.
Welcome everybody to our today's seminar. Before I hand over to Javier, let me introduce a new student in the institute, Florian Schustek. He's a student from Supélec in Metz in France, and he's going to work with us as an intern student for the next 5 to 6 months. And he'll be sitting in the electronics lab. So if he has questions, please help him.
Yeah, I think now it's working. So, well, I mean, it's a pleasure to introduce Andrés Chacoma. He has been here around for now, I think it's 2 months. Because we started in December, no?
In December.
Yeah, no, a little more than, almost 4. And well, Andrés is a postdoc here, hired in the project of with Pera Esotecos, and in the part of the SIG. But before that, he did the PhD in Argentina, in the Instituto.
Yes, in Balseiro Institute.
Mm-hmm. And well, I mean, the story is more or less this. So essentially, you did the PhD, and after that, you came here directly.
Yes, not so much.
Mm-hmm. So he's going to tell us something about the work that he was developing during the PhD, and what the procedure.
Thank you, Jose. Thank you for coming. Okay, my idea for today is to talk about the social experiment that we carry out in order to try to understand which are the underlying mechanisms in the process of opinion formation dynamics. So, I split the talk in 4 parts. In the first one, I'm going to give you a brief introduction to the topic, just for getting some context. And the second one, I'm telling you about experiment features and details. And in the third one, I'm going to share with you the most interesting results we obtained. And in the last one, I'm showing how we use this experimental data to set up and run an opinion formation model. So, start with the introduction. Social psychologists were the first to study the influence phenomenon. The experiment carried out by Professor Ash and Professor Migran, for instance, in the 60s, provide evidence for phenomena like conformity, obedience, social pressure, and influence as well. I'm not sure if you know about this kind of experiment. And so I prepared a short video I want to share with you. Give me a second. Can you hear something? This is the ASH experiment.
The volunteer is told that he's taking part in a visual perception test. What he doesn't know is that the other participants are actors, and he's the only person taking part in a real test, which is actually about group conformity.
The experiment you'll be taking part in today involves the perception of line length. Your task will be simply to look at the line here on the left and indicate which of the 3 lines on the right is equal to it in length. So, for example,
the actors have been told to match the wrong lines. The volunteer will be monitored to see if he gives the correct answer or if he goes along with the opinion of the group and gives the wrong answer. In the first test, the correct answer is 2.
1. 1. 1.
Another short one. Have you seen this? This is about social pressure. This is amazing. So social pressure exists, you know. So later on, these first qualitative observations were taken by people from natural science to define rules and build the first opinion formation model. For instance, the Boder model or the majority rule model. Snaha models. And in a total different approach, the people from cognitive science have been trying to design new experiments to get data and build more realistic models. In this area, we can find just a few works, among which we can stand out the paper by Mehdi Moussaf, for instance, really interesting paper, Jean Lawrence or Claudio Tesone, people who really trying to measure or quantify the influence and the opinion change. Our work falls into this category as well. And the problem here is the social process involved in the opinion change depend on plenty of social variables which are practically impossible to measure or quantify. So the idea in this kind of experiment is try to keep it simple, try to reduce the universe, reduce the context, and other social factors as much as we can for measure. So with this idea in mind, we designed the experiment which main features I'm showing you in the next section. So, our experiment. In this social experiment, the people have to take a 20-question survey when they are asked to estimate some quantities. For instance, in this one, we ask how many tons does another blue whale weighs. So the people have to estimate. The experiment is divided into two rounds. In the first one, we show 20 questions like this, and we ask for a numerical response, it means the opinion, and for a confidence level about the given opinion accuracy. For instance, this guy here answered 1,000 tons, and with a confidence 3. We rank the levels between 0, which means no clue about my opinion, and 5, which means completely sure. This guy, 3 is almost sure, something like that. In the second round, we show the same 20 questions again, but now we try to influence in the individual. How? Well, we show some references here. For example, for this question, we show all the participants answer 100 tons with confidence 1. So the idea is let the individual check over his previous responses and give him the opportunity to change them if he wants. Both the answer, the opinion, and the confidence could be changed in the second round. Another details. The experiment was always carried out in the presence of a supervisor. It means the people that don't have access to source of information. It was anonymous, without time limit, and unpaid. And of course, we never said that we were studying influence or social dynamics, nothing like that. We just said that we were studying how the people process and exchange information. A total of 85 undergraduate students from the Balcerro Institute and the National University of San Luis, there in Argentina, took the questionnaire. For every individual and for every question, we record the answer and the confidence on the first round, the given references, and the answer and the confidence in the second round. We collect a total of 1,700 answers, with only 56 outliers. Here the people in San Luis with the questionnaire, as you can see, appears in a computer screen. So the experiment is pretty simple. You just ask for an opinion, you measure, then you try to influence the individual by giving reference, and then you measure again in order to see if the individual changed or not the opinion. So now I'm going into the results. Any questions so far about this?
How do you select the information you give? So you give the average, you give a random answer from some random individual?
So the confidence are taken from uniform distribution. The references, the opinion reference, we chose in a range 3 sigmas over the real value.
No, the clue you give for the second round,
yes,
you choose randomly?
Yes, random.
So it's not the opinion of one of the people?
No.
You invented a...
Yes, we take it randomly. It's the same for other people.
Okay.
What do you tell them when you give the reference information? They think that it's from other participants, or they know that it's a...
In San Luis, they asked me that. We said that it was from another experiment, a previous experiment. We said that.
And when you say within 3 sigma of the actual value, how do you get to the sigma? Because a blue wave...
Thinking in our uniform normal distribution with standard deviation 1.
But of what the sigma of the answers, or because the weight of the blue whale is somehow distributed. Like a grown-up blue whale can have different weights, but maybe you ask for a year or something, then there's no spread, right? Where do you get this spread then from the sigma? Or is it always something like a blue whale's weight which can have a spread?
I think it's always we have this.
Okay.
Yes.
The outliers, what are outliers?
The outliers are people, for instance, that you ask for how many discs have the Beatles, the band The Beatles, and they ask 1,000. I think we...
Even after the second, if these are after the second round. These are outliers, people who answer something completely absurd after the second round.
In the first round, also.
Yeah, but probably there were more outliers in the first round.
I don't remember it.
Probably
yes.
The people who answered that the well weighs 1,000 tons was clearly an outlier in the first round, but probably in the second round was not.
I don't remember.
Anyway, you said some plausibility threshold, say... certain answers are simply.
Yes, I think it was more than 3 sigmas. It was the criterion. Something else? So, results. Before anything else, we analyzed the opinion distribution for every question. We saw in most cases a log normal shape. That's because we decided to work with the opinion logarithm, just for simplified analysis. Additionally, we normalize every distribution by using the mean and the standard deviation. In this way, the main advantage of doing that is the data become dimensional, and you can compare among different questions.
So if you have, say, the weight of the whale, you put there the logarithm of the weight of the whale without normalizing to that or anything.
Yes. If you take the logarithm of this distribution, you get a normal distribution. For instance, here is all the data together, because we normalize and you can get together all the data. It's just one big single data set. Okay? So, the first trace of influence shows up in this plot here. Here we have the average confidence as a function of the opinion and standard deviation. For every question, those are the questions, before and after the references. It means first round and second round. We can see in most cases the confidence grows where the dispersion drops. It seems like the references make the people more confident and at the same time less heterogeneous among them. So it is clear that there is an influence effect here caused by the references. The question is how we can quantify this effect. Well, for that we define the influence index as a number given by the opinion change divided by the difference between the reference opinion and the original opinion. In this way, if the index is 0, it means that the individual doesn't change the opinion. If you put here, this is second round. If you put here this one, you get 0. If the index is 1, it means that the individual take the given reference has a new opinion. And if the index is a number between 0 and 1, it means that the individual pick a middle value between the reference and the original opinion. So using the index, we can classify the behavior of the people in 3 categories: the people who keeps, the people who adopt, and the other who make a compromise. It is kind of mental average that people make. Going into experimental data, we can see that most people behave like keepers. But we can see also a good number of people who adopt or make a compromise. But the common behavior is to keep the original opinion, 61%. So, using the index, we saw a remarkable correlation between the confidence and the behavior. Here in this plot, we have the fraction of people who keeps, the fraction of people who adopts as a function of the confidence difference between the confidence in the first round and the reference.
Were there not any people who changed their answer in the other way? Because I mean, it would be negative if they changed it to the other side, right? And there was no.
Yes, sorry. When that happened, we put in as a compromise.
Ah, okay.
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 Yes, thank you. What was it? So in this plot, 5 means that the individual answered the question with maximal confidence. And we were trying to influence them by giving a minimal confidence. So it's logical that all the people here behave like keepers because they feel an extreme confidence about the given opinion. In the opposite situation, minus 5 means that the individual answered the question with minimal confidence and and we were trying to influence them by giving a maximal confidence. So it's also logical that most of the people behave like adopter here. But we can see in this case a good number of people who decide to keep or make a compromise, still in these conditions. So, and this is interesting because it's showing that sometimes the people doesn't behave like rational individual, as many social models frequently propose, and not only opinion formation models, economical models, for instance. So this is important. This effect is important to model. Finally, in order to summarize all the information we collect, we plot the influence map. The map gives the behavior of the people as a function of the parameter space. We have here the confidence difference, the opinion differences. The differences are always between the original one and the reference. The different colors means the three categories of behavior: keep, adopt, compromise. The ellipses in this case gives the standard deviation intervals around the mean for each distribution. So we can see in the map that there is no defined zones for each behavior. We see rather overlapping points in all the map. It seems to be a correlation between the confidence difference and the behavior if you follow the ellipses. This fact restates that we saw in the previous slide. On the other hand, we cannot conclude that there is a correlation between the opinion difference and the behavior. When I say opinion difference, I say the quantitative opinion difference among the people who interact. There is no correlation. And this is interesting because it seems like the confidence difference it seems to be more relevant in order to change the individual opinion than the opinion differences. And we have in the literature many models, many opinion formation models that frequently propose to model the opinion change as a function of the opinion quantitative difference among the people who interact. And according to our measurements, we can conclude that there is a correlation between the opinion difference and the behavior. So this is also interesting for modeling. Okay, the idea now is try to use this experimental data to build an opinion formation model. So, any questions so far about the result? I'm going to modeling now. Okay, model. Let's suppose that we have a well-mixed population where the people discuss a public debate. Each individual has an opinion and a confidence. And one interaction, one of them could become influenced by the other. Our model proposed that the influenced one update his opinion and his confidence following this equation here. The first one is the update in the opinion, which is essentially given by the influence index. The second one is the update in the confidence, which is essentially given by the confidence change. Both the index and the confidence change enters the model has a stochastic parameter given by the experimental data. I mean, which distribution are taken from the experimental data. Any question about that?
Well, when you say that, because R is the result that you show to the people, no? In this model. Capital R. Capital R.
Capital?
Capital R is the model, is the result that you show to the people on the second round. No?
Sorry, I don't get that.
Capital R is the result.
Yes, this
that
one.
You show to the people after the first round, on the second round.
And the second round.
Yeah. And then,
I mean,
I is the result that is adopted. So I is equal to 1.
yes, the index could take three values, 1, 0, and some value between 0 and 1.
Okay, so the 1 will be for the adopter, the 0 will be for the keeper, and the other 1 will be for the...
Yes. Yes. Is clear? And in the change in the confidence change, we take it from this distribution. It's more easy. It's easier. The final rules, we study the opinion's evolution. In this plot, we have the opinion first and second moment as a function of time. As initial condition, we use the opinion and confidence distribution taken from the first round experiment, the original ones. And so we can see that the system quickly achieves a full consensus final state where all the population share the same opinion. And we can see also that this final common opinion match with the mean of the initial distribution. On the other hand, we introduce in the model the presence of opinion leaders. The leaders are those people in the society that are more influenced in the society than the common people. For instance, the politicians, the journalists, or celebrities. We model the leaders as follows. Their opinion never change. They have maximal confidence always. And they have more interaction frequency than the common people. If we run the simulation with this super agent into, and we study again the opinion first and second moment as a function of time, we can see that at the end all the population tends towards the leader's opinion. We can see also that there is a process of 2 steps. At the beginning, the population goes towards the mean of the initial distribution, but then turns towards the leader's opinion.
Sorry, I'm missing something.
Yeah.
In the model that you write down, there was no direct interaction between the people. The people were given a number, R, capital R, which is a sort of whatever, mean field, external forces. So all the elements behave the same way. Where is the network of interactions, or where is the leader there on the whole dynamic changes?
I mean, let me see.
Here there is no interaction between people. This is art is any of the individuals and is given
The interaction
information capital R.
The interaction is given by the index, because the confidence of the people enters to the index, and here we have the stochastic parameter.
So you have a population of people, to each one given a random number between 0 and 1, which is this I.
Yes.
Or a random number distributed according to this distribution.
According to the initial distribution that we take.
Well, according to the initial distribution of confidence or no confidence.
Confidence and opinion that we take from the first round experiment.
No,
Okay.
The capital R is not the reference, it's the opinion of the other elements. So they are
No, capital R is the same reference for all people.
No. Here,
Explain what is this?
no.
It was a random number.
Every individual has an opinion and a confidence. Maybe it's better if you look here. Each one has different opinions and confidence. So,
But and a different capital I.
I mean,
Each one has a different
maybe
opinion,
you-
a different confidence, and
maybe
different
you
value
move-
for capital I.
forget this R because it's confused. You can use just as R, a similar.
No, the idea is that you choose one random agent and another random agent that is
Yes.
the values.
Okay,
That's a well-mixed population.
Okay,
That's
this is not
the,
experiment.
but the experiment was the capital R was the same, was given to everybody the same value. Now here you choose among your neighbors one of them, and you seek his opinion, and then you change according to some number I that tells you if you are willing to change or you are not willing to change.
yes,
No?
that's correct.
I changes from round to round for the agent. So they are given an I and they keep that I, the influence index for each agent. Is changing from round to round or is the same all the time?
No, it depends on the confidence. If you take the two people with different confidence, we maybe have different influences. It's stochastic.
So you get I from that?
Yes. For instance, this is 5. This is 0. Here we have 5. So the index is 1. Something in the middle is we have the probability given by this distribution.
But then, if I am an individual, I have to know my confidence and the confidence of the other people to determine if I am going to copy or not to that people.
This is the idea.
So it's not only I have to know my confidence, I have to know the confidence of the other people.
If he knows a lot,
Politicians have a maximum confidence. That's what they say.
So it's clear?
Mm-hmm.
Yes? Okay. I want to talk about so the final common opinion here is again, it's again a full consensus final state, but here we have this final common opinion matched with the leader's opinion.
The confidence also goes to the same value or?
No, the confidence change in this distribution.
Okay. Also in the final state, when all of them have the same opinion.
Sorry?
When you run the model and you see that actually they all go to the same opinion, the confidence of all the agents are also different, or are still different? Or
yes, we get something similar to this.
Okay.
I mean, you can think in the confidence and the opinions have two processes totally different. So this is one with only one leader. The obvious question is what happens if you have more than one opinion leader. So let's suppose that we have two leaders with different opinions and different interaction frequencies. We can see that for low values of interaction frequency, the final state is a partial consensus final state with the mean or the final distribution in some point between the leaders' opinions. Whereas for high values of interaction frequency, we can see that the population becomes split and we get a polarization final state. So the question is if this kind of outcome has any connection with the reality. We can see that, at least qualitatively, the model captured this final common scenario after a long public debate, which is the case in presidential elections. This plot is the Argentina presidential elections, the final opinion scenario, just before the presidential elections. In these particular elections, the indices define the elections. So we consider that it's interesting to try to understand this behavior in the final solution. And there is people working in that now, there in Bariloche. So just a final comment to summarize. In the experiment, we can see this influence effect caused by the references. We found this remarkable correlation between the confidence and the opinion change. And we can also see that the confidence difference seems to be more relevant in order to change the individual opinion than the opinion quantitative differences. In the models, we use the experimental data to set up the stochastic parameters involved in the opinion and confidence change. And we build a model based in these real observations. Besides, we can see that the model captures very well the final common scenarios in the set of opinion formation models, which are the full consensus, partial consensus, and polarization. And there is also analytical results in the paper. I'm not showing that now, but you can check in the article if you're interested. So this is the end. This is the reference. Professor Damián Zanetti is the co-author. He's in Balser Institute, in Bariloche, in Argentina. These people here helped me with the experiment. The girls in San Luis, and my friend Rodo in Bariloche, and these institutions involved. So this is it.
Okay, questions?
I see two strong differences between the experiment and the modeling. I don't know why, or you plan to change the model or to change the experiment to make them more similar. The first one has already been said. In the experiment, you give the people a random opinion instead of an opinion of another user, which perhaps will be more appropriate for the modeling. So I don't know why did you do that. And second, you are in the model, you are running the process for thousands of consecutive experiments, and in the experiment you only those 2 runs. Yes. I am sure this will make a difference.
Yes, I agree.
But so, can you comment anything on that?
We are trying to design an experiment to try to understand, try to study this kind of the problem with many consecutive process. And about the other, the first question is, is what we decide. We consider that it's okay, but it could be.
But in the model, you can easily put a fix. This will model better the experiment.
The model is model and experiment is experiment.
They are quite different. This is what I say.
Yes. I will use a part of the experiment to set model, but different things, totally different things.
Okay. More questions?
I think it's more interesting the experiment, but it's pretty simple to show.
But in the experiment you have external forcing fixed for all. You give the same information to all the people. So I think you have a question. While in the model you have an interaction between people, and you can get different opinions at different times, and you have an evolution over the time. And the fact that this evolution over the time of interacting along many people not necessarily is the same that giving the same information once to everybody. It's a different perspective. Also, another thing, in the model, you have the people interacting, how they interact all to all. You randomly choose another node and you interact with them.
Yes, it's a well-mixed population.
And in the first result that you saw from the model, it seems that there is some oscillation, or maybe that's not there. And if that was just one round, or
this one?
An average of several rounds of the experiment?
This one?
At least for the average. Yeah.
You're talking about that?
Yeah. Is that something that we wash out? Is this one realization or many realizations?
Yes. No.
Even spray.
Yes, there is an average.
But that's time.
Okay.
So that's an average of many realizations. So that oscillation is real.
Yes.
How does it come about? This is one realization.
This is
I don't know.
I don't remember. It could be one realization.
This is not one realization.
This is not one realization.
This is not constant. This is very. The mean value is very defined.
Yeah, but once the opinions are
it's
not well defined.
You have a big system after many interactions, all interacting to all.
But why do you think that is weird?
At least the equation should give some clue on how this is happening, no? If there is an oscillation. or it's just
It's a common block.
You have to buy walls, so maybe.
Yeah. It gives us a blue.
Why the standard deviation is decreasing like that? Is any explanation?
Is because it's go down in logarithm way. Exponential. It's a logarithm.
If not, well, thanks.
Gracias.